This is the third of my videos on oscillations, simple harmonic motion, etc. And I'd like to talk about resonance, something that you need to know about. Okay, first of all, damping. If an object is oscillating like a mass on a spring freely, it won't bounce up and down forever. Eventually its oscillations will die away, and that's due to something that we call damping. And damping, when an oscillating system loses energy every cycle due to friction. It may be air resistance or some other kind of friction, but what happens is that the amplitude of the oscillations, a free oscillation, will decrease exponentially. Note, however, that the period stays the same. It's just the amplitude which decreases. There are two types of oscillation. There's free oscillations and forced oscillations. A free oscillation, like a mass on a spring or a pendulum, just oscillates at its natural frequency. A forced oscillation is when something is made to oscillate by some kind of external force. If you pick something up and shake it, then that is a forced oscillation. You're making it oscillate. We can investigate resonance using this apparatus here. If you imagine a mass on a spring attached to a vibration generator, and we slowly increase the driving frequency and measure the amplitude, we get this graph which shows what we call a resonance peak. You should definitely learn the shape of this graph. It will occur when the driving frequency is equal to the natural frequency of the system. Learn this phrase at the bottom. When the driving frequency equals the natural frequency, large amplitude oscillations occur. This is called resonance. Learn that word for word. If resonance is a problem, for example, it may be a bridge resonating when soldiers march over it, or due to wind or whatever, then you can do a few things. You can increase the amount of damping. If you increase the damping, then the resonant frequency will be the same, but all of the amplitudes will be smaller. The other thing you can do is change the natural frequency of the system so that the natural frequency becomes one at which doesn't match the driving frequency. You could do that by changing the stiffness of the supports.